Good morning, dear students. Welcome back to your online class. Today we will discuss a new topic of the chapter heat. What? Convections. Already we know that about the convections, some basic points now. In first class already we have discussed about the convection. What? It is also a mode of transfer of heat. It takes place in case of gases and liquids. Okay? Convections take place in case of only solid. Convections takes place in case of liquid and gases. Okay? And I already have given one examples. Okay? For better understanding this point, convection. How heat energy will flow from one point to other point through convection process. Okay? What examples just I had given? Just take some toffees. Okay? A teacher enters in a class and he want to distribute these toffees among the students. So by conventions, how he will distribute these toffees to the students? Just he calls each students one by one and give the toffees to them. Okay? It means it shows the actual movements of students. Okay? So here we can say that in case of convections, when heat energy will transfer from one point to other point in a body by this process, here the actual movement of molecules takes place. Actual movement of molecules takes place. So we conclude this. What? The process of transferring of heat energy by the actual movement of molecules throughout the process. Okay? Clear? In this process, convection is the process in which there is a actual movement of molecules perform the transferring of heat energy from one point to other points. Okay? Now we can again understand this point with some activities or experiment. So here first one is given. Here just we take a container, okay, or a beaker, pour some water in the beaker, okay, clear, and also pour or drop some small teeny pieces of paper, okay. Then just put up this beaker over a wire gauge on a tripod stand, with a wire gauge or on a tripod stand. Under the tripod stand, just we will put up a Bunsen burner or a spirit lamp to provide the heat energy, and that's act as a source of heat. Now, when the heat energy will supply from this street lamp is the source to the beaker, okay. So the molecules of this water, means liquid, gains the heat energy, and what you will observe? The molecules of the water gains the heat energy and becomes riser. But you can't see the movement of molecules. So that's why here we put up or we dropped some small pieces of paper, teeny papers. So when the heat energy will transfer from this source to the beaker, these teeny small papers or pieces, what? They will show their movement. They becomes raised up. Okay? Clear? ये आपको ऊपर उठते हुए दिखाई देंगे. जो टेनी pieces पेपर के हैं वो ऊपर से आपको दिखेगा. So this shows that what? There is the actual movement of molecules, and these warm molecules that gets heated thus replace the cold molecules from the upper layer of the water. Means the cold molecules start going to downside, start going to or shifting to downside. In this way, this process is repeated. Again, the hotter molecules just reached upper layer, then cold molecules is to the downside. Okay students, you can again at least easily understand this topic through a inverted video. Okay, so watch this video, enjoy this video and try to better understand this point. Okay, then we will discuss the second one, that again it shows the conventional current or the actual movement of molecules. Okay students.
Convection, the process by which heat is transmitted in liquids and gases by actual movement of molecules, is called convection. Liquids and gases are bad conductors of heat, and so heat is not transmitted through them by conduction. Let us see how heat is transmitted through liquids and gases. When liquids and gases are heated, they expand, become less dense and rise. The molecules from the colder portions flow downward to take their place. These molecules get heated and rise. This continuous process results in the formation of a current called convection current.
Welcome back again. So, students, next one. Here, again we have to show that how the molecules of the liquids actually move. Okay, actually they move when they raise the heat energy. So here, we take a stand, clap stand, a rectangular glass tube with a funnel. This rectangular glass tube attached with a funnel, and a Bunsen burner as a source of heat, and a small piece of potassium permanganate KMnO4. Now again just you will see here we drop the KNO4 or we pour the KNO4, this potassium permanganate, in the rectangular glass tube and provide the heat energy at this end, this one corner end at point C. So after few minutes you will observe that this potassium permanganate will move, means here its molecules are start to move from where? This side A, then A to B, then B to C and C to D. Okay, here how? Because when they gets heated, the volume of this potassium permanganate that is already inside the rectangular glass tube increases, so its density decreases. So we know that if any body if its density decreases, it becomes fall down. So the molecules of the potassium permanganate, when its volume decreases, goes to downside, means from A to B, B to C and C to D. Okay, and then again it reaches to the other positions. So in this way, this circular motion is continuing. Okay, in the same way, means the molecules of this potassium permanganate are continuously moving from A to B, B to C, C to D. So here again it's represent the convectional current or convection process of the liquid. Already I have told now, convection takes place in gases. Okay students, so first you will just try to understand better this point. Okay, through again a better edited video. Okay students, so enjoy the video and just try this one. Then again we will proceed to the next point. Convection takes place in case of gases. Okay students, so enjoy this video and try to better understand.
Experiment. Convection of heat. Let us learn about convection of heat in water. Take a round flask and fix it to a stand. Fill the flask with cold water. Then carefully drop a few crystals of potassium permanganate to the bottom of the flask. Now, heat the water by placing a Bunsen burner with a small flame under the flask and observe the crystals. When the water at the bottom of the flask is heated, it expands. The expanded water is less dense than the surrounding water and therefore starts to rise. The cooler region of the water in the upper part of the flask, being denser, sink. Observe the colored water rising up the beaker side, go across the top and then sink down to the other side of the beaker. This is called convection of heat in liquid. Now let's get to know about convection of heat in air. Take a closed rectangular box with glass fitted to its one side. Pierce 2 holes at the top of the rectangular box. Fit 2 glass tubes at the top to form chimneys, chimney A and chimney B. Place the candle below chimney B. Light the candle. Hold the smoldering piece of paper over chimney A and observe the movement of the smoke. You will observe smoke entering the box through chimney A and gets heated up by the candle and comes out of chimney B. This is because the air above the candle gets heated and expands and is now less dense than the surrounding air. It rises out of the chimney. In doing so, the cooler surrounding air, being denser, sinks through the other chimney to replace the less dense air. The movements of the hot and cold air set up a convection current. The smoke produced by a piece of smoldering paper held above the cooler chimneys make the convection current visible.
Again, welcome back, students. Now we will discuss about the what? Convections takes place in case of gases. How convections current or convections takes place of heat energy means transfer of heat in case of gases. So for that, again we will perform one more activity. Here we take a wooden box, or you can say that thermocol box, okay? Wooden box or cardboard box, in which its one side is transparent. If you want, you can just put up a transparent sheet, okay, either a glass sheet, and take 2 chimneys A and B. Take 2 chimneys, means it's also transparent glass chimneys A and B. One this agarbatti, okay, and a candle, burning candle. Now set up these operators according to figure. Here at the top surface you will put up these 2 chimneys A and B, and inside the box under the chimney B or below the chimney B you will just put up a burning candle. Burning candle. Now bring the smoldering agarbatti near the chimney A. Smoldering agarbatti near the chimney A. So what you will observe that the smoke of this agarbatti will flow towards the downside to the box, and then it will again come out from the chimney B. Comes out from the chimney B. How it is possible? Because when we bring this smoldering agarbatti near the mouth of the chimney A, okay, so the density of this smoke, means gas, due to the heat energy present inside the box. So density of this gas, means this particular gas that is produced by the agarbatti, is decreases and its volume increases. So it falls down, means the heat energy that is already present inside the box with the candle just strips all the smokes of the agarbatti and flows out from the chimney B. Out from the chimney B. Okay, clear? Means the smokes of this agarbatti just falls down or go through the chimney A inside the box, and due to the decrease in density and increase in volume, all these smokes shifts with the heat energy and flows out through the chimney B. Okay, so here again shows that all the molecules, means they moves and they transfer the heat energy from one point to other points. Okay, students, clear? So this shows that the movement of molecules in case of gases. This represent the convectional current. On the basis of this concept, convectional current, the one more things based, ventilation of the room, of the air, ventilation of the air inside the room. Okay, inside the room, when we are breathing means when we take the breath, a huge amount of carbon dioxide just comes out from our body, and also some gases present inside the room, they becomes hot, they make the room warmer. So the windows is that is the present in the rooms, they help us to transfer this warm air to the outside, means flows out the warm air, and through the doors, means from the inside the cool air comes inside, means that is the circular process of the going, means out and coming, outgoing and incoming of the air. So due to this, the freshness of the air inside the room will maintain, and so that easily we can just take the oxygens and just remove or you can say that relieve the CO2, okay, by the process of breathing. So in case of ventilation, the process by which impure and warm air inside a room is continuously replaced by the fresh air from the outside. It's called ventilation. Means this ventilation is also based on the process of convectional current. Okay, students, clear? Here also the circular motion of the air, means the actual movement of the molecules. Warm air goes outside and fresh air comes inside. This is the called ventilation. Clear, students? So these are some terms and activities which shows that how convection takes place in case of liquid and gases. In next class, we will discuss about the third way or the method to the transfer of heat, that is the radiation. Thank you. Have a nice day.